Hello, today I am going to discuss how to find the tank weight based on the millivolt per volt signal generated by the weight transmitter. So before I go into the detail of the discussion, let me briefly talk about the load cell information. Maybe I draw a picture, it's easier to understand. Right. Okay. Let's say this is a tank. Alright. So the tank on top of the tank maybe got a lot of piping, and also it have a valve. It may connected to the flexible hose, transmitter, etc. So below the tank there is a four legs or stands. So below the stand or the leg there are four load cell. Okay, these are four load cell. Okay, we call it load cell. So we total got four load cell here. Okay, load cell is basically a sensor that is used to measure the weight of the object placed on top of the sensor. Okay, so this load cell will have the signal wire connected to the summing board. All right, so this is a summing board. And then the summing board is just a electronic board where it will average out all the signals, millivolt per volt signal generated by each load cell. Okay, and then send the average output signal to the weight transmitter. Okay, so before we go into detail, we understand just some information, basic information about the load cell. uh Okay, so we have to understand what is the meaning of dead weight. Okay, dead weight is just a fixed weight or static weight. Okay, just a static weight. So basically, when you do not fill in any product or water into the tank, so the weight that measured by the transmitter is called static weight, or basically just an empty tank or empty vessel. So live weight is called dynamic weight or net weight. When you fill up the water or product into the tank, right? This is the live weight or net weight. Okay, so what is the meaning of current millivolt per volt? Current millivolt per volt. Okay, this transmitter will measure the current millivolt per volt as well as live millivolt per volt. Current millivolt per volt is the raw millivolt per volt generated by the each load cell. Okay, each load cell will generate the current millivolt per volt based on the weight applied to the load cell. Okay, and how about the live millivolt per volt? Okay, live millivolt per volt is a compensated millivolt per volt, meaning when you apply the tab or apply the zeroing to the weight transmitter, this millivolt per volt will be compensated, and it is called live millivolt per volt. Okay, so inside the transmitter, there is a zero button as well as tare button. T-A-R-E-D. Tare button, once you press, it will zeroing out all the weight that measured by the transmitter. Usually, tare button is pressed when you want to achieve net weight. This one, net weight of 0 kilogram. Okay, so the the next incoming product or water will be your net weight instead of cross weight. Okay, so cross weight is the dead weight plus the live weight, or what we call net weight. Okay, all right, so now we need to find the weight. Okay, the tank weight or the product weight based on the millivolt per volt generated by each load cell. Okay, how do we find out? So in order to find this, we have to know the load cell capacity as well as the load cell rated output. So in order to find out these two things, we have to refer to the load cell datasheet. So for today's discussion, I have prepared a datasheet for your reference. This is the datasheet for the load cell. The load cell model is KDH-3 and the capacity here is 100 kilonewton. This is the capacity of the load cell that we use for today's discussion. I use this 100 kilonewton capacity. And the other thing I need to find out is the rated output. This is a rated output value, 2.0 millivolt per volt signal. This signal is a full load signal, meaning if you apply 100 kilonewton full load to the load cell, it will generate this maximum signal of 2.0 millivolt per volt. Alright, so now we already have all the information. We can start to do the calculation. Okay, so one more thing that we need to know is excitation. Excitation is basically the supply voltage. Okay, let's say for today's case, I use a 10 volt. Okay, you can find out the excitation voltage by using the multimeter to measure the excitation terminal behind the weight transmitter. Okay, and based on the data sheet of the load cell, the load cell capacity is 100 kilonewton. All right, and then the rated output is 2.00 millivolt per volt. Okay, so in order to calculate this is very simple. Since we use not only one load cell, we use 4 load cell in the system, so we have to calculate the system capacity. The system capacity is, sorry, 4 load cell times 100 kilonewton capacity, which is 400,000 newton. Okay, there are different unit of weight. It can be kilogram, it can be pounds, etc. For today's discussion, I use a kilogram as my weight unit. Okay, so let's say I this tank is empty. So the weight the measure by the weight transmitter is a dead weight because the tank is empty. That means it's the static weight of the piping, the empty tank, the valve, hose, agitator, etc. without the product. So this is the dead weight. So let's say the dead weight millivolt, okay, millivolt per volt generated by the transmitter when the tank is empty is 0.536010. All right, millivolt per volt. Okay, and what is the dead weight in kilogram? So it's easy to calculate. We can calculate in such a way. Okay, as we know, the system capacity is 400 Newton. And Newton, this Newton is a unit of weight or force. As we know, force equal to mass time gravity or acceleration. Because we want to find the weight in the unit of kilogram, we have to find out the m, the mass or the mass. So the g will transfer to here. So it becomes force divided by g. And the g is 9.81. Okay, so this is equivalent to 400,000 divided by 9.81, and then you will get about 40,774.72 kilogram. All right, this is the system capacity in kilogram. The rated output with excitation is with excitation is this excitation 10 volt multiplied by this rated output 2.00 millivolt per volt. So you will get about 20 millivolt. So it can be rewritten as 20 millivolt is proportional to 40,774.72 kilogram. So if my dead weight is 0.536010, so you have to change this one to, instead of millivolt per volt, you have to change to millivolt so that the unit will be the same like this one, millivolt. So you have to time 10 excitation voltage, which is 0.536010 times 10. You will get about 5.36010. Okay, so 5.36010 millivolt, you will get about 5.36010 divided by 20 millivolt multiplied by this kilogram, 4774.72, and then you will get about, let me calculate, 10927.83 kilogram. This is my dead weight, which is this one, dead weight or static weight. Okay, how to find the live weight? What is live weight? Live weight is the net weight or the product weight. That means when I fill out the product or water inside the tank, I need to find out the net weight or the live weight. Let's say the live weight millivolt per volt given is maybe 0.99 0.99822 millivolt per volt. So this one had to convert to live millivolt per volt with excitation. So you have to multiply by 10 and then you will get 9.98022. So 9.98022 millivolt, okay, live weight, okay. What is the corresponding kilogram? So it is 9.98022 millivolt divided by 20 millivolt multiplied by this rated output with excitation 20 multiplied by this kilogram. 40774.72 kilogram. So you will get about, just hold on, let me calculate. 2374 2347.03 kilogram. Okay, this is a live weight. Okay, this one live weight or the net weight or what we call the product weight. All right, so that's it. Thank you.